So that's question 1. Let's move on to question 2. On question 2, it says at time t, a position of a particle is moving in the xy plane is given by the parametric function x of t, y of t, where dx dt is given by this differential equation. The graph of y consists of these 3 line segments shown here. And it says at t equals 0, we're at the position 5, 1. They want us to find the position of the particle at t equals 3. So I know that x is going to be equal to 5, which is my initial x value, plus the integral from 0 to 3 of dx dt, which is going to be equal to 5 plus the integral from 0 to 3 of this t squared plus sine of 3t squared dt, which comes out to be 14.337. And I can look from the graph to find out what y is going to be at that point. Y, when t is equal to 3, is exactly halfway on this line segment, so y is 1/2. So the position is going to be the point 14.337 and 1/2. So I found the position. Now I need to look at slope. Remember that slope is going to be the change in y over the change in x, but because we're parametric here, this is really going to be dy dt over dx dt. So I need to figure out what dy dt is and dx dt is when t equals 3, and that just means substituting 3 into this function. So this is going to be 3 squared plus the sine of 3 times 3 squared over, and dy dt is actually going to be the slope of this line, which rises 1 unit and runs 2 units, so over 1/2. And this is a beautiful way to leave your answer, but because it is calculator section, you could say that it's 0.050. That would also work. For part C, they want us to find the speed of the particle. Remember that the speed is going to be the square root of dx dt squared plus dy dt squared. So I'm going to have to substitute this in what happens when t equals 3. So for us, it's going to be the square root of 3 squared plus the sine of 3 times 3 squared plus dy dt, which we saw was 1/2 squared. And again, this is a perfect form that I could leave my answer in if I really wanted to, but I could also type this in my calculator and get 9.969. Again, the thing to be careful for here is that because I'm using a trig value, I need to make sure that I'm in radian mode for part B and part C. So make sure you're in radian mode when you're doing these calculations on your calculator, otherwise you could run into some problems. So moving on to part D, says they want us to find the total distance traveled by the particle from t equals 0 to t equals 2. Now the way we would normally find this is we would say that the distance equals the integral from 0 to 2 of that speed that we just found. So x prime squared plus y prime squared dt. The problem is from 0 to 1, y prime in this case ends up being -2. But from 1 to 2, y prime is 0. So because y prime is constant and different on these intervals, I really need to treat this as the integral from 0 to 1 plus the integral from 1 to 2 of each of these terms. So I'm going to have the square root of t squared plus the sine of 3t squared squared plus -2 squared dt plus, and then the integral from 1 to 2 of the square root of t squared plus the sine of 3t squared squared dt. Again, because my y prime is 0 on here, that's missing. And so I'm going to need to evaluate this on my calculator, and calculating it out, I get 4.349. So I get a pretty straightforward question on here. So that's our calculator section. That's problems 1 and 2.